to do is they show you the 3D solid, and they give you the dimensions of the length, the width, and the height, and they want you to lay this out on how it would look as a net. When you do this, here's my suggestion, my advice, my strategy. Figure out how many of each shape you need. How many total faces are there? In any rectangular prism, there's always how much? There's always 6. So you know you need 6, but you got to figure out how many what we call unique shapes there are. Because and I'll hold up the actual prism to show you what I'm talking about. Every prism has a matching set of parallel sides, right? So if you figure this out, the dimensions of the front should be the same dimensions as the what? The back. The left piece is going to have the same dimensions as the right, and the top has the same dimensions as the, okay? So how many unique faces are there? This is kind of, the one I'm holding up is kind of not a great example. Go back to this, because how many unique shapes are there? Or how many unique faces are there? So, all right, look, stop a minute. Ready? This is a 3. What's this? This is 6. Put that on your sheet. Therefore, the back is what? 6 by 3, right? Because the 6 by 3 is matching and parallel to the back, which is a 6 by 3. This piece on the right is a 6 by 7. What's this? This is also 7. What's this? What's this? What's this? What's this? Okay, so we have the front is a 6 by 3. It matches up with the back, which is also a 6 by 3. So that's not a unique shape or a unique face. So you have one that's 6 by 3. This side piece is 6 by 7. It matches up with another 6 by 7. So now we have 2 unique faces. And then what's the third unique face? Unique means one of its kind. 7 by 3. So you have a 7 by 3, which is the top. The bottom is not a unique face because it matches up with the top. The one that's facing you, the front, is a 6 by 3. That's a unique face. It matches up with the back, which is not unique. It's just a carbon copy of it. And then the right side is a 6 by 7. And the left side is a 6 by 7. So you need a total of how many unique pieces? 3. Well, how many altogether? 6, right? So you need 2 pieces that are 6 by 3. You need 2 pieces that are 3 by 7. And you need 2 pieces that are 6 by 3. Huh? Don't worry about it. Okay, so here is our inventory of our shapes. This is all 6 pieces. And then you want to start to put together piece by piece. Well, it doesn't matter where you start. I know that this 6 by 3 on the front, oops, I don't want to do that. Now I do need that marker. Okay, so the 6 by 3 is attached to what on the right side? The 7 by 6. So I'm going to bring that right up there. Okay, now you got to kind of visualize. On the opposite side is what? You got a 7 by 6. Watch what I'm doing. I'm kind of drawing it or arranging the pieces from the front to the right. Now I need the back piece. What's the back piece? Another 3 by 6. And that's connected to the side that you can't see, which is the left panel, which is what? Another 6 by 7. Now I need a top and a bottom. I need the 6 by 3 is attached to a 7 by 3, but I've got to rotate it, don't I? Okay, so this is going where? And I could also put it here if I want. I can, but I'm going to put it here. And then the last piece is here. Almost drawn perfectly to scale. Okay? All right, you got to draw it. These pieces can also go here if you want, as long as it's attached to that 3 by 6. You can do it that way too. If you put it together, it's going to make the 3D rectangular prism. Okay, the triangular prism. How many total faces will you need, or how many total shapes when you assemble it? Not unique, total. You need a total of 5. How many of that are unique? Look, count carefully. There are 2. You have, right, here's what it looks like when you lay it out. I have 3 rectangles that are all measuring 3 by 6, so that's one unique shape, and 2 triangles that are probably right triangles, even though they don't stipulate that. Oh, I'll fix that. You're right. I'll fix that. All right. Okay, fixed. So we have 2 unique faces. The rectangle, which is 6 by 3, and the right triangle. I'm assuming it's right because it's an equilateral. Actually, equilateral triangles are not right triangles, but for the most part right now, leave them the way they are, okay? It's okay. Okay, so I think this is easier to assemble than the rectangular prism on the previous page. You have all 3 rectangles that are attached to each other, right? Because you have a rectangle, and on the other side you have another rectangle attached to the long side, and then one underneath. So you wind up with this here, and then just attach your 2 triangles on opposite sides, and you'll have it. You go here, well, I'll go in the middle. I'm going to, I have to. And the numbers are going to flip with it, but that's okay. And that'll work. Yeah, you know what? Let me do that. Here. Doesn't match up perfectly, but you get the gist. Size-wise, like that. Unique means one of a kind. Like once I have a 6 by 3, that's a unique shape. The other ones are replications. Okay? What I mean by unique shape, I mean unique means one of its kind. We only have really one shape that's 6 by 3. It just repeats 3 times. We only have one shape that's 3 by 3 that repeats twice. Okay? It becomes important when we do the next phase of this lesson called surface area. Try the next one on your own. I think it's the easiest out of all 3. What's your inventory first? Raise your hand. How many do you need? And what are the dimensions? Juliana. That measure what? Okay. That measures. Okay, there it is. There are your parts laid out. Assemble it. Okay, so there's your 4 triangles and your 1 square. Let me do it only because it takes time. Sometimes it's a little tricky actually to do it. How'd you do? Okay. Okay, let's do total faces first. How many total faces? By the way, what shape is that? What shape is that? Foz? What's the 3D shape if you put it together? Correct. How many? It can't be a cube. Well, if you have any faces that are not the same, then it's not going to be a square prism. It's going to be a cube. It's going to be a rectangular prism. How many total faces? Taylor? Nothing there yet. Taylor, how many unique faces? Mm-hmm. Does everybody see why there's only two unique faces? Okay, watch. Watch. This face right here measures 2 boxes by 2 boxes. So does this one. Okay? So this and this count as like one unique shape. Okay. Then what's the height of this? What's the width? This is a 2 by 1. 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 So that only counts once. So you have two unique faces. Okay? So the reason why we do unique faces is because it saves us work in trying to figure out something new now called surface area. Surface area is not volume. It's the area of the faces that make up that shape. The surface of that shape. That's what surface area is. Whereas volume is length times width times height, which is totally different. That's how much space can fit inside that three-dimensional object. Surface area, and again, I don't have a shape that matches this identically, but if I just want to know the area of the surfaces or the faces all together, that's called surface area. That's called a broken piece. It didn't break, it's okay. Okay? So, first few pages, they do it as nets, and then you got to try to figure it out as a 3D shape. Okay, so we have two unique surfaces. One of them measures, let's do the square first. That's a 2 by 2, right? So to figure out the area of that square, you would multiply what? 2 times 2, which equals 4. Okay, that's one unique surface. Base times height. I haven't gotten to it yet. All I'm doing is the unique faces right now. Yes. Watch. 1, 2. 1, 2. Okay, the second unique shape. What are the measurements of the second unique shape? Mallory. 2 by 1. What's the area of the second unique shape? What's the area? Okay. Now we have to find out how many times each unique shape repeats. How many that measure an area of 4? Times 2, right? So if you wanted to, all you got to really do is just do times 2 for a total of 8. Yes? How many unique shapes, or how many times does this unique shape repeat? So this is a times 4 for 8. And then you add it all together, what do you get? area of 16, and here's how you prove it. Yes. Because there's 4 of them that are 2 by 1. Go ahead. Because look, there's 2 shapes that measure 2 by 2. There's this one, and there's this one. And then, if I color code, I've got 4 that measure 2 by 1. Okay? So what's the total? 16. Here's how you check. Count all the boxes inside the shape. Count up all the boxes inside the shape. What do you get? 16. So this is 16 square units. Okay? Next shape. This one. Total faces. Total faces, Addison. 6. How many unique faces? Be careful. Count carefully. Well, let's just do it together. This one is 1, 2, 3, 4, 5. 5 by 1, 2, 3, 4, 5. That's a 5 by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is also a 5 by 5. So I have 2 that measure 5 by 5. Okay, what about these guys? 1, 2, 3, 4, 5 by 2. 1, 2, 3, 4, 5 by 2. 1, 2, 3, 4, 5 by 2. And then this guy's a 1, 2, 3, 4, 5 by 2. Okay? So we have 2 unique faces. 5 by 5 for a total of 25. Oops. The second unique face is 2 by 5 for a total of 10. Okay? So it's unique face times how many times it repeats. 25 times 2, right? Times 2 makes 50. And the 2 by 5s repeat how many times? 4 times. 1, 2, 3, 4. I'll even number them. 1, 2, 3, and 4. So that's 40, right? So the total is 90 square units. Okay? 90. 90 square units. They give you more lines than what you need. If you wanted to do each piece individually, you could. I'm trying to show you the shortcut because I know you guys like shortcuts. Okay, try this on your own. How many total faces? And you should now know that all rectangular prisms always have 6, including the cubes. Unique faces. Better count carefully. Watch, watch. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay? This one. 1, 2, 3, 4, also 5. 1, 2, 3, 4, 5, 6. Okay, so this unique shape matches up with this one. Okay? Now, let me do this. 1, 2, 3, 4, 5 by 1. 1, 2, 3, 4, 5 by 1. So this is a unique face. Now, if these were 5 by 1, you would be fine, but they're not 5 by 1. They're 6 by 1. 3, 4, 5, 6 by 1. So you have 3 unique faces. Okay, so let's just do it. I have a 5 by 6, right? For a total of 30, right? It repeats how many times? So I got to do times 2. That takes care of my 5 by 6 rectangle. Okay. The green piece, or the side pieces, were what? 5 by 1, right? Total of 5. Repeats how many times? Only 2 times. That takes care of that. Third unique piece is what? Mm-hmm. So now you've got to add your 12. You've got to add your 60. And you got to add your 10. And you get 82 square units. Okay? Okay, next. Dylan, can you move? Come over here or somewhere. Just move. Who's over here? Michael? Sit over here, Dylan. I'll make room. Yeah, no. Right here. Okay. How many total faces? Can you see? You're working on your own anyway, right? How many total? No, total faces. Total faces. 5 total. Unique. 2. What makes this a little bit trickier, though? The triangles, right? So you got to do base times height divided by 2. Okay? We have the height, though, Lauren. Look, we're okay. Here's my base. Here's my height. So I'm good. Okay? Okay, so we'll do the square first. Let's call this unique shape 1. How many by how many? 4 by 4. For a total of, and that's done because that's the only one. All right, my triangles, which I'll call shape 2, unique shape 2. Dan, base and height of my triangle. 4 by how much? 4 by how much? Yes, by 3. Does anybody need me to explain how we got 4 by 3? Where? The unique shape number 2. Total is 12, right? However, how many of them are in that unique shape? So you got to do times 4. Correct. I forgot to divide by 2. Thank you. So 4 times 3, but I got to divide by 2 because it's a triangle. So this becomes 6 times 4. Correct. It's 40 total units. 40 square units. 40 square units. Okay? Why 40? 24 plus 16 is 40. Okay? Okay. So now when you go to the next page, they figured now you've graduated and you don't need squares in the middle. Now you actually have the actual 3D shape. We're still going to handle it the same way with unique faces. Okay? Now I think it helps, listen, I think it helps to label as much of this as you can so you can see it. So if this is 15, what's this? And then what's this? So all the horizontals on the long end are 15. This is 8, so its opposite edge is 8. And its opposite edge on the long side is also 8. This is 6, so what's this? And that makes this what? Okay, this is going to help you to see the unique faces. Unless it's a cube, unless it's a cube, there's going to be at least 2 unique faces. Sometimes there's 3. This one has 3. Sometimes 2, but if it's a cube, only 1. Okay. Total faces on any rectangular prism is always 6. All right. So, unique faces. Does everybody see why it's 3? Okay. I have, look, I'll color code it again. I'll use a highlighter. It's fine. I have a 15 by 8. That's 1. Then I have, what's this one? That's an 8 by 6, isn't it? And then I have this one, which is a 6 by 15. That's my 3 unique faces. Okay? All right, so we only have to do, instead of doing 6 calculations, we're really only going to do 3 calculations and just multiply it by 2. All right, we'll call this 1. I'll call this 2. And I'll call the top 3. What are the dimensions of face 1? 15 by 8, yes. For a total of, you want to multiply it now or multiply it later? Times 2. Okay, that one's done. Greg, dimensions of face number 2. 8 by 6. Total, before we multiply it. Nope, you can do it in any order. 48 times 2. 96. Matt Gannon, unique face number 3. Dimensions, please. Sounds good. 15 times 6 is now 120. 15 times 8 was 120. 15 times 6 is 90. 15 times 6 is 90. You're getting it confused with shape number 1 because shape 1 is different dimensions. Shape 1 is 15 by 8. Shape 2 is 15 by 6. So what'd you get? Riley, what'd you get as a total? 516. And everybody, it's still area. Don't get confused because you see the 3D shape. It's not asking for volume, it's surface area. So once you hear that word area, whether it's surface area or not, it's going to be units squared. Do they give you the actual dimensions in measurements? Yep, call it centimeters squared. Because they tell you the size of centimeters, so you can use it. Sorry, 5/16 square centimeters. Well, we're out of time. We have to do it after lunch.